Hello, this is Sam Gregory and Tony Sitko's presentation on chaos theory and exploring everything about it.
Chaos is defined as the inherent unpredictability in the behavior of a complex natural system by Merriam-Webster. In normal terms, chaos essentially means random events following one another, with each event isolated having an unpredictable outcome. Chaos theory is the idea that the initial conditions set for an event will cause a radical change in future events in the event chain. The butterfly effect is derived from this ideal in its exemplary form. It is said that a flap of a butterfly's wing in Brazil can lead to a tornado in Texas. The butterfly effect is to say that any minute difference in the initial conditions of a system, one single butterfly flapping its wings, can cause extremely different outcomes to the system's end/future events, a tornado in Texas forming.
Art school is sought after by many people. Many end up in bad spots at the end of their schooling and end up impoverished and without much to their name, such as famous artist Vincent van Gogh. Adolf Hitler was amongst these people. He had failed out of art school. This was at the beginning of his descent into madness. Soon after, he found himself in jail. There he actually was the model prisoner, and he got out early on good behavior, all while writing his infamous book known as Mein Kampf, which translates to My Struggle. This book detailed his plans to essentially taking over Germany and then over the world, as well as his hatred for Jewish people. He then went on to start his political career, got Germany in his back pocket, and started World War II, and in the process killed millions of innocent people and soldiers. It is thought that Hitler's failures of art school is where his radical beliefs first began. Should he have succeeded in his art career, our world could have been a very different one. Millions of families would have been still around, and Germany could have still been impoverished, and the United States would not have been the major world power that we see today. The story of Archduke Franz Ferdinand of Austria-Hungary is a very important one. He decided to visit a part of Austria-Hungary at a very inopportune time. He visited a town on the anniversary of a battle in the town. A radical group of terrorists known as the Black Hand had decided that visiting the town at that time was an insult, and they decided to assassinate him. Most of the assassins failed, but Gavrilo Princip, the leader of the assassins, was just at the right place at the right time. Due to a driving mistake, the royal driver passed by Princip with Ferdinand. Princip apparently barely got Ferdinand, but he did eventually die shortly thereafter. This sparked anger in Austria-Hungary, blamed Serbia for the assassination because they were from a sect of Serbia. That caused a chain of alliances being forced into battle starting World War I, ultimately killing millions and ruining Germany's political and economical status. Should Franz Ferdinand's driver not made that driving mistake, potentially both world wars could have been avoided altogether, and the picture on screen is of the Archduke Franz Ferdinand himself. Early American colonies thrived off of the idea of salutary neglect. This was the idea that Britain let the colonies do their own thing out of respect, and let them naturally grow. Salutary neglect ended when Britain realized that the colonies were grown enough to actually start paying their fair share of Britain's debts through taxes. This angered the colonists, who banded together against the taxes like the Intolerable Acts and the Stamp Act. Here they simply called for representation in Parliament, and they promised they would stop their crying should they get their representation. If they had been granted votes, and they might not have actually gone through with the American Revolution, and might not have become the superpower we know today as the U.S.
Snowflakes are considered to be a chaotic event if the formation of each one is taken into consideration. Snow is formed when water vapor turns directly into a solid through deposition. It is said that there are no two snowflakes exactly identical due to the chaotic nature of this change from water to solid. Storms are caused by opposing fronts moving in on each other and colliding. The eye of a storm refers to the epicenter where the two hot and cold fronts meet. Where and when they meet is complete randomness, and the storm that is formed from the two meetings is never exactly the same. They could possess different levels of precipitation and arrange in varying wind speeds. When plants grow, they tend to grow towards light. Even though the plants may be of the same species, the grow rates of each are different. Several factors are at play here: the nutrients in the soil, condition of the seed, and amount of sunlight it gets. It would be impossible to perform the process of exposing the plants to the exact same condition.
Irrational numbers are numbers that go on forever in a decimal sequence and cannot be simplified to a fraction. Popular examples of these would be values like pi or e. They follow no specific pattern and thus are completely chaotic in nature. We can, however, derive specific values of a certain digit, such as in the 100,000th place of pi lies the value of 9. We use these values nearly every day in our learning, and their chaotic nature has caused many to simply remember their values. Fractals are a series of patterns that repeat themselves and appear to go on indefinitely. They have both perfect and multiple lines of symmetry. Fractals are randomly forming and cannot be recreated. They only occur from nature and are used to define the patterns on shells and the bark of trees. As we know by now, the future is nearly impossible to predict. Using existing information and statistics of prior similar events, we can often predict changes in our future. People do this daily with the stock market, purchasing, and with economic growth. By the laws of chaos theory, this type of prediction will eventually fail to predict accurately. On the same token, however, we can shape the chaos that follows an event with initial conditions set, as many companies do in order to maintain profits.
Jerk is the third derivative of displacement with respect to time. It is measured in meters per second cubed. The jerk equation, which describes how to arrive at a value for jerk, can have chaotic results if you use a minimal amount of data to arrive at the value. This variability is one of the reasons jerk is seldom used in physics. The double-rotted pendulum is a perfect example of how initial situations cause drastic changes in the system's travel pattern. If you drop it from an even slightly different angular height, the entirety of the drop will change from one chaotic pattern to another. Not only does its initial settings affect the entire fall, but the entire fall itself follows a completely random pattern. Where the bottom rod falls has a huge difference on the bottom of the rod's trail, causing the rest of the system to follow its erratic pattern. On screen is a free body diagram of certain points of a double-rotted pendulum swinging, showing that each point is affected by gravity with a different angle of force pulling it in varied directions. Every scientist deals with chaos theory in one way or another. This is due to human error. Their essential goal is to replicate their experiments perfectly every time. To do this, they must have the same initial conditions each time. This can change, being marginalized by accounting for human error in multiple trials, but it cannot be vanquished altogether. Every experiment will have some percent error, and by minimizing it, scientists are controlling and containing a chaotic variable.
Catastrophe theory is derived from chaos theory. It states that in dynamical systems, such as the jerk systems mentioned earlier, a sudden shift in behavior naturally occurring from small changes in circumstances is caused by the conditions set initially in the system. It basically means that immediate changes are a product of the conditions far prior to the potential catastrophe, such as a nuclear reaction explosion. The Kolmogorov-Arnold-Moser theorem basically means that if you add a small variable to an answer you already knew while trying to find a new unknown, you can estimate the true value of the unknown. The small changes to the answer depending on the variable added are chaotic. You could be nearly perfect on the correct answer, and you could be off by a larger percent error. This theorem creates a range of values that could be a rough gauge for these unknowns, but has chaotic values with nearly every new calculated answer. The Earth's formation itself is chaotic. When the Earth was a ball of magma located in the Goldilocks zone, a Mars-sized object came crashing into the Earth, which shot out a chunk of rock that we today refer to as the Moon. If this event did not take place in the Earth's early days, then we wouldn't even have a moon. Tides would be completely different and only based on the sun, and life could have potentially never existed in the first place.
Until Dawn is a game that builds the story upon chaos theory. Certain decisions dictate which characters will live and how said characters will carry out further interactions. The choice of giving another character a high five in the game could result in the death of multiple characters in the future. A core element of the game is the butterfly effect. The characters themselves mention it, and it is even considered to be an actual element in the game. Throughout the game, it shows you possible death of the characters. It is up to the player to either avoid or seek out that character's death, even changing their actions to avoid it. The simple act of running at the right time and hiding at the right time in the game could be one of the deciding factors, and the game lets you choose what happens. In the movie adaptations of Batman, the whole plot line is that Bruce Wayne adapts to what he fears the most to avenge his parents' lives after being gunned down in an alley. Watching the robbery gone violent occur in front of him had scarred him for life and made him promise to rid the streets of Gotham from crime. However, if the family just had told the butler to pick them up at the front of the cinema, the whole crisis could have been averted and the Batman never would have surfaced. The story of Game of Thrones starts off 20 years after King Robert's rebellion. In the show, it is revealed that the rebellion was caused by Lyanna Stark and Rhaegar Targaryen falling in love and running away together while telling absolutely no one about it. They made the entire world fight for her on the assumption that she had been kidnapped and held against her will. This caused the fall of House Targaryen and partially the House of Stark, as well as the grasp for power of the House Lannister. If they had actually told someone their plans, then their baby Aegon Targaryen would have been legitimized and grown up to be king instead of being raised as Ned Stark's bastard child, Lyanna Stark's brother. If this one event hadn't occurred just as it did in the show and books, then the entire story would be different. There might not have been a plot line at all.
In reflection, we learned that chaos theory is pretty awesome if you do consider outside the box thinking. It can be used to link two seemingly completely unconnected events without any need for direct correlation. It is extremely interesting to consider all the possibilities in both history and in our own lives if some small change were to be made. It did not change our perspectives on mathematics per se, but it did change our perspectives on pretty much the world and events that occur in it, such as how seemingly small elections in our local government and local world, and how it can eventually shape the larger world and larger politics. Such interesting topics are why people pursue mathematics and sciences, and it's why I pursue it as well. These important discoveries shape our modern-day philosophy and our future generations' knowledge pool.